Hello, this is a tour of my battery connected solar PV system. When I was trying to figure out how to set one of these up, I watched a lot of videos on the internet, so I thought I'd better make one to return the favor. So the two panels I have on my roof are two 280 watt SolarWorld monocrystalline panels. Those are connected to the batteries. I also have a grid-tied system, which is much larger, which I might talk about in another video. But here's the tour of the battery connected system. So the 280 watt panels are connected in series, and they come in here through here and connect into they go through the charge controller. Actually, first the positive goes into this breaker box here, and you can see this breaker is connects and disconnects the solar PV in. From there, the solar connects into this charge controller. This is a 60 amp TriStar MPPT charge controller. You've got to have the MPPT if you want maximum power out of your panels for battery connected systems. From there, charge controller goes again back into the breaker box through this breaker, which is the connection to the batteries. So this will disconnect the batteries from the charge controller. I also have these two breakers here, which are together make a ground fault protection device for the two panels on the roof. So if there ever were a short or ground fault between the panels and the ground, this would trip. And my understanding is that's to prevent fires. So from here, the charge controller is connected to the batteries, so that goes down here to here's the battery box that I built, and in here are two 153 amp hour SunXtender solar batteries. So these are made specifically to do renewable energy applications. So these are true deep cycle absorbed glass mat sealed batteries. So these don't vent. They don't vent hydrogen gas when charging, or they vent a very small amount, a much smaller amount than the regular lead acid batteries. But these are lead acid, but they're absorbed glass mat sealed batteries, so they don't require watering or maintenance or anything like that. So and you can see these are connected in series as well. They're each 12 volts, so this makes, connected in series, this makes 24 volts. So it's a 24 volt system, 153 amp hours total. So it's not a huge amount of power, but these batteries are really nice, way better than the things I got from Batteries Plus that I used to be using. But so these, even without any sun, I figure on my experience so far is these batteries will run my internet router modem plus this chest freezer for about 2 days before they need recharging. So that's about down to 50% discharge of the batteries, which is about as low as you want to go. So these are great so far. And in the summertime, which it's summer right now, the PV system, there's more than adequate sun to recharge even from a 50% depth of discharge. I really don't even usually get down to 50% discharge in the summer so far. I'm somewhere between 25 and 35% discharge usually in the summertime. So these are great. In here you also see the this is a fuse that is this is the positive lead coming out of the battery bank going to the inverter. So this is a fuse. This is a 100 amp fuse to protect from any overcurrent from the inverter. So that's there. Also on the outside of the box here I have a DC disconnect, so in case of emergencies or just want to make sure that the inverter is fully isolated, you can turn this switch here and fully disconnect the inverter from the batteries. So we've got overcurrent and a disconnect. So that leads me to the last part here, which is the inverter. Connected here is a 1000 watt pure sine wave inverter, 24 volt inverter connected to the batteries. And right now I've got, coming out of here, I've got a connection going to the chest freezer, and then one that goes up into the living room that's powering a one LED light. It continuously powers the cable internet, both the router and the modem, the Wi-Fi router and the modem, and then it's also hooked up to the stereo when I run the stereo. So it's usually on a regular day, I think the chest freezer plus those other pieces of equipment are drawing somewhere in the maybe 1200 watt hour range pretty consistently on a daily basis. So they're pulling about 1200 watt hours out of the battery on a regular day, if I'm not running the stereo for a long time or anything else. And again, this is these sets of panels are more than adequate to power that. So that's it. You can see the rest of the things here. Everything obviously is hooked up to a common ground here, which goes out to earth ground. These are just the internet connection for the charge controller, so you can read all the information about what's going on from the charge controller over the local Wi-Fi network, and you can log data. It's a great feature of this charge controller here. But in the future I might upgrade this to be more of like a DC disconnect system, but this works just fine for what I have right now, and it was much lower cost than some of those bigger boxes. So that's it.